In this video, I'm going to go over how to solve rational equations. And this is going to look a little bit different to how we did the adding and subtracting rational expressions. So just make sure you're practicing enough to know the difference in both of the approaches when you see an expression as opposed to an equation. All right, so these first two here is just like, how would you solve these? I guess the first thing I would do is I would move the 3/5 over to the other side to isolate for my variable, that variable d. So then I would have 2 times d equals 1/2 plus 3/5, right? And like we did in our kind of fraction review from middle school, we need common denominators. So this is going to be 5/10 plus 6/10, which is going to be 11/10. And then what I would do is, to make this a little easier, is I would normally divide both sides by 2, right, to get d by itself. But because the other side is a fraction, I'm going to multiply by 1/2, which is the same as dividing by 2. So multiply by 1/2, and that would allow me to get my unknown here, which is going to be 11/20. Okay, let's look at the second one. All right, second one, we have 3 instances of our variable n. The first 2 happen on the same side of the equation, so I'm just going to add those together. Right, that's 1, which is really 4/4. So that becomes 5/4 n equals -3 plus 1/2 n. I'm going to subtract the 1/2 n to the other side to be with the other variable n. Now again, I need a common denominator, 5/4 minus 1/2. Leave the 4 alone. This will become 2/4 to get 3/4 n equals -3. And I hope you guys remember from your middle school days that if you have a fraction in front of your variable, instead of writing dividing by 3/4, we're going to multiply by the reciprocal of 4/3, and that will make it just n by itself. So this is going to be n equals negative, and as I told you guys before, right, when you're multiplying, you want to look diagonally first to see if you can reduce, and we can, right? 3/3 becomes 1, so this is just going to be n equals -4. All right, so that's how I would solve both of those. Now, for rational equations, the way this works is that at least one of your kind of things in the equation has to be a rational expression. Now, you'll notice like in letter A, we've got 2 of them have denominators, and that first one actually doesn't have an x in the bottom. But letter B is going to have 2 with x's in the bottom, and C and D both have, or I should say all 3, have variables in the denominator. So I'm going to show you how we deal with this. The first thing I do with these problems is I find the least common denominator. Okay, now I know this, I mentioned this in my last video, is that I know you think of lowest or least common denominator, which is what it is, but it really means it's just, you got to capture everything, right? And I'll put this over 1. So capturing all these denominators when they share nothing in common, right? That 2, this x plus 1, and that 1 have nothing in common besides 1. So the LCD is going to be all of those multiplied together. Don't need to write times 1 because that's not going to change anything. So how I'm going to do this, different from what you saw in my previous video on adding and subtracting rational expressions, is that I'm going to copy them all down. Notice I'm going to leave some space here in between things. And now, instead of getting a common denominator, I'm going to use this LCD to multiply every single term here, all 3 of these rational expressions, times the LCD. And by doing that, I will eliminate my denominators. Let me show you. So multiply by 2 times x plus 1. And the nice thing is with these is once you find the LCD, you don't need to do like with the expressions where you're like, okay, which one does this one need? This one is like everyone gets the same thing, okay? So here's how it works. I'm going to look diagonally to see what crosses out. So with this first one, the 2's cross out. With this next one, the x plus, don't want to do that, that's erasing. The x plus 1's cross out. And with the last one, nothing crosses out, right, with that 1. So here's what I do. Once I cross out the stuff that's going to go away, I'm going to multiply this x plus 1 times the 2x minus 3. All right, that's what's remaining. Plus, what's remaining here is the 2 times the 5x. And finally, like I said, nothing crossed out there. So it's going to be 2 times x plus 1 times x. And now you'll notice every single denominator is gone. All right, let's go ahead and distribute. I get 2x squared minus, let's see, minus 3x plus 2x is going to be minus 1x, and then minus 3, plus, this will be 10x, equals, I'm going to do all this together, right? So the x times x is x squared, but times 2 is 2x squared. The x times 1 is x, times 2 gives me 2x. Now this becomes a quadratic equation. Actually, you'll notice it is for a moment with quadratics, but I have 2x squared on both sides, so those are actually going to go away, and now it's a linear equation where I want to get my x's to one side and my constants to the other. So let's go and combine like terms. Negative x and 10x is 9x, minus 3 equals 2x. I'm going to move that 2x over to get 7x, move the 3 over, the minus 3 over to get positive 3, so x equals 3/7. Now, when you solve a rational equation like we just did, you always need to check to make sure that this solution is not going to make any denominator in the original equation become 0. And really the only thing I had to worry about was this denominator here, x plus 1. That's the only one that has a variable in the denominator. And if I plugged in 3/7, right, 3/7 plus 1 in that denominator would not be 0. So this is okay, all right? But you always want to do that check. Those are called extraneous solutions, and I'm sure we'll find one here soon. If you find a solution after you do all your work, but you plug it back in and it makes 0 in any of the denominators, just has to do it for one of them, then it's not a solution. It's called extraneous, all right? All right, here we go. I'm going to put this over 1. My LCD is going to be x minus 5. And that's the same denominator in those two, and this one's just 1. So I'm going to write x over x minus 5 plus 5 over 1 equals 5 over x minus 5. All right? I'm going to multiply by that LCD of x minus 5. And you're going to see what crosses out. The x minus 5s cross out in the first one. Nothing crosses out in the second one. And then the third one, the x minus 5s cross out. So what's remaining would be x plus x minus 5 times 5, which is equal to just 5. Distribute that 5, and you get 5x minus 25. All right, so it's just going to be a linear equation, which is 6x equals, move the 25 over with addition, you get 30. So x equals 5. Now again, before you move on, if you were to take that 5 and plug it back into the original equation, would that cause any denominator to become 0? And the answer is yes. It actually causes two denominators. It doesn't matter, it just has to be one, right? But both of those denominators would become 0, so that's an issue. So this is called an extraneous solution. And that's the only one I found. So if this one doesn't work, right, if that doesn't work, then I'm actually going to write no solution here. Right? There's no x value that would make this true if the only one I found would make a denominator become 0. Okay, let's try C. All right, I'm going to factor this last one here to be x times x minus 3. And then that means my least common denominator is going to be x times x minus 3. So I'm going to rewrite these again, leaving that space. And I'm going to leave it as factored. I think it's always easier to do that. So let's multiply times the x minus 3 for all three of these. X times x minus 3, sorry about that. All right, last one. Let's see what crosses out. So x minus 3s are crossing out for the first one. The x's are crossing out for the second one, and everything crosses out there. So let's see what it leaves me with. So x times x minus 5 plus x minus 3 times 1. I don't need to write times 1. And then those all cross out, so equals negative 7. All right, I think we're finally going to get a quadratic here. Distribute x squared minus 5x plus x minus 3 equals negative 7. Combine like terms. X squared minus 4x minus 3 equals negative 7. Let's get this equal to 0 so we can factor. Moving that over with adding 7 is going to be plus 4. And so I'm going to factor this. I need factors of 4 that add to negative 4. So x minus 2, they're the same. This is a perfect square trinomial. All right. And so I just need one of these as x equals 2. Again, before I move on, check back with the original. Would 2 make any of those denominators become 0? No, the first one would become -1. Second one would just be 2. And the last one would become 2 minus 3 is -1 times 2 is going to be -2. So not 0. So that is okay. All right, let's do letter D. I think it's the last one. Factoring this gives me x minus 6 and x minus 2. Won't always be the case, but I tell students every year when I teach something like this is, just take a quick peek, right? It shouldn't probably surprise you that they end up being the same factors. Won't always be the case, but use the problem to your advantage. So my LCD is just going to be x minus 6 and x minus 2. So copying these down. Again, I'm going to leave that factored. All right, I'm going to multiply the numerator by the LCD with the intent of crossing out with the stuff that's in the denominators. All right, that's the whole point. All right, so let's see what crosses out. So I've got x minus 2 is cross out, x minus 6 is cross out, and actually everything crosses out there. All right, so I'm left with x minus 6 times x plus x minus 2 times 1 equals 4. Very similar to the last one. So x squared minus 6x plus x minus 2 equals 4. Combine like terms, x squared minus 5x minus 2 equals 4. Let's set it equal to 0. So I'm going to move that 4 over with subtraction to get minus 6. Thinking of factors of -6 that add to -5, I believe that's going to be, let's see, -6 and 1. Confirm. Yes, that should be good. So x equals 6 or x equals -1. Again, check your denominators. Would either of those make my denominator 0? And yes, one of them would not work, right? +6 would make 2 of those denominators become 0. So this one right here is the extraneous solution, which means that -1 is our only solution. It's the only one that doesn't make the denominators become 0. All right, so that's it. Check out the homework. Check out my key to see how you're doing. Come see me for office hours. Good luck.